Hello, welcome back to I Guess You Missed Science class. Today we are going to check in on our Rainmaker model. So if we look at what we did yesterday, we set up this model as a demo and we drew our models of what it looked like before in the light and what it looked like before in the dark. So what we are going to do now is we're going to check 24 hours have gone by. We're going to measure the volume that is left in each of these speakers, the light and the dark. We're going to answer this question: what is the difference or variable between each of the models, and how did it affect the amount of water that moved within the model? For this, think back to our celery lab. And then we're going to add arrows to our model to explain how water moved within the Rainmaker. So this is what it looked like yesterday. We're going to check, we're going to draw our models today, add any changes, and as always, add arrows to show the direction of water movement, and also our model that was in the dark. So let's check on them. So I'm walking into the lab and I'm seeing all of our Rainmakers set up from all of the classes. So let's take a look at this one. This is first block. So here's our heat lamp. It's been on for 24 hours now. You can see that there's some water droplets on the side of our Rainmaker. Interesting though, they're not on the side that's closest to the heat. They're on the opposite side. Here's second block. Same thing. We're seeing water that is on the cooler side of the bottle, and there's none on the warmer side. And in this little lip at the bottom where we folded that in, you can see that water is starting to collect down there. Here's fourth block. We're starting to see some trends. Fifth block. Fifth block's got a lot of water collecting there. Or I'm sorry, that was sixth block. Here's fifth block. All right, let's measure. So let's use fifth blocks as our example. So we're going to take the Rainmaker off. And again, there is a lot of water that has collected in that little lip down there. You can see that. And again, on the cooler side of the bottle, we have water that is collected, and on the warmer side, there's nothing. We can also see on that cooler side that those drops of water seem to be running down and collecting in the cup down there. So let's measure the amount of water that we have left. We started with 100 milliliters yesterday. And today we have about 51 milliliters left from our light model. All right, so now we're coming back into the classroom to check on our dark models. So they've been under here all night long with a sign to not disturb. Let's take a peek under here and let's see if we can find fifth block, since that's the one that we used for the light. So carefully pull it out. Turn the light on. All right. So it's about 69.4 degrees in there. I don't see any water droplets on the side of our model. I don't see any water collecting in the cup down there. Let's take this off and measure. All right, so here we are. I don't even think I need the graduated cylinder to measure, because as you can see, we're right there at 100 milliliters. So in our dark model, we have no water collecting on the inside of the bottle. We have no water collecting in the lip down there. Turn it over, there's absolutely nothing in there. It's completely dry. So using what you saw, make sure you draw what the after looks like in the dark and what the after looks like in the light. And again, for our location, or our volume, For our light model, we started with 100. We ended up with 51 milliliters left over. And in the dark, we started with 100 and ended up with 100. The last thing that we're going to do today is the next page in your packet, which is the Share Your Ideas. We're going to talk about all of the stuff that we saw in the Uncover phase, and then we're going to complete this in our packet. Now for this, we're going to use the same color coding as we did for our lot models, and when I did mine, evaporation was sort of this brown color. I don't remember what your color was, but I'm sure you do. And let me grab a marker over here. So what we're going to do is we're going to label the state that water was in before and after each process. So in evaporation, it starts as a, liquid and ends as a gas. Second thing, in each box, we're going to draw water molecules with the appropriate molecule spacing and movement for that state. Now, when I think back to the PhET model, in liquids, the molecules were sort of all staying together, but not super tightly packed. They're kind of moving towards one another so that they can stay together. And in a gas, I remember from the PhET model, they were all over the place, all different directions, bouncing into each other. I gave you that example of two knuckleheads in an elevator just bouncing around. And then we need to add an arrow to the before model to show if thermal energy was transferred into and out of the system. So I remember with the PhET model, when I increased thermal energy, the molecules broke apart and started spreading out into a gas. So I think when we add energy to a liquid, add heat, those molecules are going to start to speed up, and then they're going to evaporate off into a gas. So I'm going to draw an arrow into to show that we are adding thermal energy. So you can go ahead and do that for condensation, melting, and freezing. If you can't remember, you can always head back to that PhET model and check it out online. Hope to see you back tomorrow.